try to think some aspects of theorizing and actually the need for change in the way in which we theorize. I have been working on this for quite a long time. One of the readings which you may have read is this push to the edges, which I'm going to a little bit cover as one of the motivations for what I'm saying. So it is not only about theorizing, but for the thinking about the type of theorizing which might be useful for the community at large and why this type of new form of theorizing is needed. This is going to be relatively high level by its definition or nature, because we try to look at the sort of big picture of sort of theorizing. I'm happy to engage any questions as I move along if there are some issues which you want to clarify or understand, because the pace is going to be quite brisk, if I put it that way. And at the end, I will try to leave time hopefully about half an hour or 25 minutes for discussion. So I'm going to probably talk about 1 hour or so, plus minus 5 minutes, depending on how excited I get. So that's sort of states, and it also is reflected in the title, which is Theorizing at the Age of Digital Transformation. So, of course, this requires a number of, and I'm going to clarify first what I talk about, what I mean by digital transformation and why it matters in the context of theorizing. And as a sort of precursor or premise, we have to probably define what theorizing is. There are multiple different, of course, ways of thinking about theory. And if I were to ask you, each one of you, and write it down what you mean by theory, I would guess that there are, understand, 69 people. I probably would guess that we would get at least 30 different accounts of that. So it's not a simple thing. But I'll try to keep it relatively simple in this context, in the sense that it is an effort to explain in some form a certain outcome. There are different ways of explaining that, and sometimes the theorizing can, and the expectation is also that this explanation is somewhat transferable from one context to another, in the sense that it can be applied across several settings. But as part of that explanation, of course, you need to establish some boundary conditions where it cannot be explained. There's no theory which explains everything, and if you have a theory which explains everything, it explains nothing. So theory is always context specific, and you need to know the boundary conditions. The other aspect is that I'm not going to make any specific other types of establish any specific criteria for the type of theorizing. I will assume that there are multiple forms of theorizing which emerge from multiple different forms of inference. So theorizing is connected always to a certain forms of inference, and the possibility to vindicate or warrant the inference itself. So any type of thought or any type of imagination is not theorizing. It requires certain accepted forms of receiving or accepting the claims which are derived from the theory based on established understanding of the standards through which you can evaluate what is the acceptable form of inference. Another simple way of saying that is that theories are like searchlights, which allow you to sort of see something which you would not otherwise see, and also find a way to get from point A to point B. So which explains the movement from A to point B. But these are very different ways of metaphorical. But just to you understand what I'm talking about. And I'm going to start now the slides. It's this one. Hopefully it works. Sometimes you pick up the wrong one.
Looks perfect.
So is it fine? You can see the full open.
Yes.
All right, good. Then we are in the business. By the way, this odd-looking architectural piece here is the building where I'm working. It's a picture from one side of the building. So So I'm going to start with this thing that as information scholars, we are engaged in theorizing in a very specific context. As I clarify, the context matters. And the context is that we need to somehow explain the presence, the conditions, and the presence and the outcomes of technological agency in a social context. That's one way of putting it, what the information systems scholar. So it's a little bit different way of putting it than saying the information system. But at the bottom, if you put a larger sort of discourse within social sciences, and even it is sort of dealing with technological agents and the effects of technological agents. And this is not something which has not been gone unnoticed. In social sciences, there's a fair amount of stuff on technology and technological change and its effects on social conditions, especially in sociology and economics, and its different offsprings and subfields. But there's a typical assumption in much of these arguments, with some exceptions, is that there's an assumption that the technology remains the same, but the social setting changes. So if you have a production line, you have a production line, and it remains a production line. And it influences a certain form of, first of all, work organization, and it also implies certain forms of organizing, which are typically what we know as a corporate form, and it implies a certain form of social exchange, which is a mass market exchange. These are all connected. And based on that, they typically assume that the technology is a part of the context. So you assume the proxy view, as Orlikovsky and Iacona pointed, or nominal view. At most. So you have a certain way of showing the technology was present there. But you don't really talk very much about the technology. And this is fine. This type of assumption, it's valid and fine as the technology remains the same and its external relationships are relatively fixed while the social components around it change when the technology undergoes certain gradual change. And of course, based on that, you can say that if you look at Kondratiev fates or some economic explanations of technological change and so forth, so they typically assume 40 to 50 years of relatively fixed sort of form of organizing, and then there's some sort of smaller change, another layer of technology is added to existing fold. So in all these studies, technology provides a sort of stable background for what we want to truly see, which is the social change. So, and we talk about era of steam engine, electronic motor, and then lately computer. And of course, the acceleration of these different technologies has advanced as the technological change and science knowledge has advanced. So, and this has been the way in which, if you look at the classic studies of technological change, either Walrus or some economist Marx and so forth, these were largely very similarly sort of organized. So that you assume that there's this sort of industrial organization which applies certain forms of technologies and they change over time in a certain form. And they cover both material technologies and also material technologies which enable information exchange. Most important of them during the industrial era probably was telephone. The other technologies were like punch cards and what have you. Accounting records, filing systems, all these were part of the technologies for information exchange. And then around 1970, of course, more extensive computerization started, I would say. That's 1970, 1980s typically established as the sort of heyday of the industrial organization. And most of you probably have sort of lived at the decline of industrial organization and emergence of this, which I would call the digital form of organizing. And of course, it started with just the computers, but now the digital embodies largely everything. It's a general purpose technology which pretty much covers all social exchanges, interactions, and every walk of life which we can imagine. And it's penetrating more deeply and deeply all the time. And it's replacing and substituting things which humans did, like cognition and so forth. So we might sort of think that is this digital change similar or different from the types of changes in which the technology changed in the last 150 years? And can we make the same assumptions about the context making, that technology is just a context in which we explain social change? Or is digital something different? And this is a very deep and important question, which should influence the way in which we think about theorizing. And there are different ways of answering the question. There's no one single best or single answer to this. It's not one single truth. It's more like an assumption. But and a certain way of framing the environment or understanding the technological environment in which the social organizing happens. But different assumptions lead to different conclusions and different ways of actually engaging it, how to try to explain what is actually happening. And of course, for us, the challenge is that we are inside this change. We are not out looking at outside like electrons. We are inside it. So it also imposes certain constraints and certain ways in which actually we are engaging in this change, because the way in which we talk about that change will influence the change itself. So there is this recursivity in our theorizing about how this whole change will actually unfold as we move along, which we need to be aware of and understand. All right, so this is where we currently are. Like we have autonomous cars and many other things. Are these different than the sort of older technologies, and should we theorize differently about their impacts, the antecedents and their presence and behavior and their outcomes for social condition? That's a sort of large question which we need to ask. And if you look at how much of the IS literature has approached sort of theorizing and explaining the uses of information technology or computing, I call it sort of Chandlerian logic, which this is mostly economics, but you can also say much of the organizing or sociological accounts assume or move from similar story. In sociology, they might call it Fordism or post-Fordism, which is a very similar idea. So the idea is that you are basically producing material objects which are moved around and shaped and molded, and then they are distributed in again with certain types of technologies to certain specific markets. And the existence of organization is largely determined to what extent it can efficiently address the supply and demand fluctuation and difference between the markets and the fact of how you organize and effectively produce these types of products. So you have to find this market fit with the organization and its products. And that largely dictates the internal organizational form, which has been the corporate form in different forms, although it has evolved over time as the technologies have evolved. But the key ideas in this idea is that the benefits are largely for this organizing is to seek scale and scope benefits, so that you can produce more efficiently and with a smaller cost, or you can produce it more effectively in the sense that you produce for certain specific market niches better and more economic way than anybody else. And this has largely determined the sort of economic requirements of the sort of organization, and much of the digital technologies have been organized to enable this type of fit. And that our technologies until 90s largely reflected this. We have enterprise resource planning systems, which enable the efficiency of the internal organization, customer relationship management systems, which enable the market structure, market fit examination and search. And then we have all types of other systems which enable the efficient management of different types of resources in order to actually utilize this organizing form by human resource management, inventory control, computer-aided manufacturing, and so forth. But I'm not going to go detail, you know all that stuff, but that's basically the sort of setting in which much of the digitalization has been studied. Now, if you look at over the last 10, 15 years, when people have started to talk about digital, we have only some doodles of certain framework in which we can think about what are the effects of the digital, like the stack. I'm going to talk a little bit more about it. But the stack is very different than the idea of a product organization or bill of materials, which largely organizes or determines how you handle the nature of operational processes and integrate the market with the sort of production. Or we have some other types of ideas of affordances and infrastructures and so forth. So we have some, it's a little bit naive metaphor, which we can say that we have we are tapping this elephant from different angles, and these noodles are sort of one way of tapping each of different parts of the elephant, which we don't see fully. Whereas of course the Chandler's value was largely the fact that he started to write these pieces in 60s and 70s at the heyday, and he looked backwards, history. So he could largely actually say that what actually happened and why it happened in the way, and why this organizing form emerged to address certain types of supply and demand challenges in organizations. Now, if you move this into the context of theorizing, how we have theorized and explained the uses of technologies, that information systems is a relatively new field. Arguments go when it started, but around the 70s, at the same time when the heyday happened of the corporate form. So we have been riding on the decline of that form as a sort of a disciplinary formation. Where would we pick up the theorizing to explain this thing? We pick up the theorizing largely from the accounts and disciplines which have explained the rise of the Chandlerian system. And we have followed largely similar types of theories or general theories about how humans make certain decisions and choices about certain things, like how they apply technologies, how they accept the technologies, or how they use them in a certain sense, either individually or as organizations. So much of and this is from the sort of 250 paper with Varun. So if you look at how most of the scholarship has been conducted, not all, but most of that. So you typically identify an interesting problem or category in the way in which we can explain the use of certain type of system, certain type of technology in a certain organizational setting in this Chandlerian regime. Then you go, sorry to say the word, you go to the theory supermarket, which is that there are all these theories, which might actually have a certain relevance for explaining this thing. And you typically, if you are a smart PhD student, you buy the cheapest one. You probably can see the metaphor of market fit here too. So it's easy to apply. It has credibility. Others have used it, so there's followers of that, or it has a strong market position. It has a reputation, and it has easy to use. It works. So it has validity, and it has instrumentation. Makes life much easier. Then you adapt the theory into the context or the phenomenon itself. Like if you look at the transaction cost economics has been applied, for example, to inter-organizational system integration problems. Or resource-based theory has been applied to the notion of how organizations make choices about IT strategy. Then you build a model and develop instrumentation. So you pick up some aspect or construct from that theory, and then you map them into the sort of this context, and you fill them with certain words which include IT or systems. Typically the scales, if you do survey studies, or you find analogs if you are doing sort of archival studies. Then you sort of run you are well equipped in the statistics or regression models, so you run and test the models. You refine the model until you find some sort of good story out of it, good results which you can narrate with that theory. That's largely how much of the work has been, much of the research has been done. And I'll show some evidence of that. So what happens here is that you have a sort of relatively, actually you start from relatively practical and concrete, but then you go to the very high abstract level of abstraction, which is the very broad, wide abstract theory of certain things like transaction cost theory. You contextualize it into your problem, which build a certain type of mid-range account platform, and then you sort of find some results. And if you find a good model, good findings, you can build your career out of that. So you can expand it to new context. You can add, do incremental changes. You can add moderators, mediators, what have you. So you can build a sort of stream of, and it is fine with it, but this is typically how you build your academic career. Now, when we wrote this paper, the senior editor, the editors who actually said that we don't buy your argument. They said that, well, that's not how it works. We have much more indigenous theory in our field. So we did an empirical study, although this is a little bit outdated, or to validate it. And we pick up 100 articles randomly from MI's Quarterly and ISR over the period of 2005 to 2015 or so. And then we coded all the articles and look at the theoretical model and look at to what extent they had a change or minor, no change or minor change in the model in relation to the theory which they were following. Whether they did some moderate change or extensive change. And you can see that most of the articles didn't change the actual theory, didn't introduce any new construct, no new relationship or nothing like that, which could be implied. And much smaller percentage did some moderate changes or extensive changes. And the 55% were such that the IT was not theorized at all. It was treated as a nominal or proxy. Whereas 24 was IT was used as an artifact that used as a tool or computational capability. So only less than 20% looked at IT holistically as in a socio-economic context. So in most cases, the theories were borrowed and tested without much change in constructs or logic, or recognizing that or making any assumption whether the digital is different from any other type of element or technology in that setting. And of course, it limited theorizing of IT, and it was treated as exogenous in most of these studies. It's not part of the actual theorizing of the phenomenon itself. It is an outside effect, which and you explained it with the theory that sort of outside effect on the social condition. And we did also, Baron did a similar study on a specific theory, very similar results on the transaction cost theory. And he looked at all the articles in IS which have used the transaction cost theory and found that 65 didn't make any changes, 33 moderately changed and adapted to the IS phenomenon, and only 2% substantially changed based on the IS phenomenon, or were critical of it. So this is like one specific theory that it has been mostly adopted uncritically using its constructs as is or modified on logic to explain whatever you have already. But there's no question whether we should start thinking about does it really help us to explain what is the phenomenon doing, or what is the actual effect of this the technology in itself in this context. So you can see that clearly it is in all these studies follows the similar type of social tradition of that the technology remains static, and we are and it's in the context, not the thing which we need to theorize about very much. So if you look at what are the outcomes of this type of approach, mostly it has resulted in the fact that we have largely outsourced abstract ideas from outside. We have created a platform, and we have created largely a closed loop systems. And I'm going to clarify the last one later on. And we can raise a number of issues. Are we addressing, by doing this, important questions? Probably we start with important questions many times. But the way in which we explain them, are we addressing really the important question around that question? And the explanation which we are providing. And is this the best way to allocate resources? Is this the best way to theorize? Is this should we improve our own theorizing about the phenomenon and treat, for example, a digital or this technology much more seriously? And which would imply that we build some type of indigenous theory. In the article in 2015, we largely explain also try to explain the reasons for this. One of them is, of course, the political battles and the sort of validity and legitimacy of the field, especially in business schools, and demonstrating that we have theories and we have rigor in what we do. Now, and more important, as we already raised in 2015, which is now 10 years later, is becoming much more important, is that how does the import of these questions change as we move to pervasive digital environments? When it's pretty much part of everything which we do. And is there something new in these type of environments, how we should think about the digital and theorize about the digital? And should we theorize in different manner and get rid of this type of what we call this type of epistemic script of borrowing theories. And does the script work in these settings? And as we put it, should be moved to edges. So give up the script, at least not always do it, rather follow the phenomenon, or rather do very high-level abstract blue theorizing, which is currently not very easy to do in our environment. And are there any caveats of this? And we can say that one of the reasons, of course, is that why this is important is this move to the digital. The fact that we are using different term now. We talked about IT until 2004, 2005, and then after 2010, people started to talk about digital. There was this special issue in ISR when it turned 20 years, and there were a number of articles, a couple of those written by me, which emphasized that we are in a new environment, digital environment. And after that, this term has picked up. It has also, of course, one of the reasons is that consultants figure it out. And now it's a sort of a term which is used everywhere so that it doesn't have any specific meaning, really, in practice. Everything is digital. It looks like people have forgotten that IT existed. And why do we have these two terms? Of course, for the consultants, it is largely the way of selling new things, new ideas. They might be old, but you have to sell as new many times. But for scholars, it is a real important issue. If we change the term, we need to have a reason for doing it. And then we wrote in this other article, which I'm going to shortly review in 2023 with AB and Varun mainly, and then Alok and Werner were also involved to some extent on that, where we try to say that what is different in digital X from ITX. By the way, a short note. I ran a seminar in 2008 when I was on sabbatical on digital innovation. And I put that syllabus of that seminar on the internet. And for a few months, it was if you wrote digital innovation into the Google search, it was the first thing which came up. So around 2007, 2008, it wasn't very widely used word. And I don't know what the algorithm is and why it came up as a first, but it shows that it wasn't at all the sort of hot button term as it is now. So it changed in a very relatively short period after between 2008 and 2013, 14, in that 5-year period. Now, if you talk about digital, the issue is that what is digital? There are, the first aspect is that if we compare history of computing, the technology, the basic architecture and the principles are exactly the same. It's a von Neumann architecture, digital computer, bits and zeros. And you have mostly silicon which runs it. That hasn't changed. Material foundations have not changed. The actual operation and architecture of the technology has changed in principle. The sort of very fundamental principle has not changed. But it is very different now because it's a general purpose technology and it has certain features it didn't have before, I would say, 2010 when since after 2000 when the internet emerged. And the first one is that now it's infrastructural. So it is not just a system, it is a system of capabilities and components which can be integrated and combined in multiple ways for different type of reasons. And it has this type of generative capability to expand by itself, which systems have a very little capability because they are typically contextualized in the specific functional task for a specific context. ERP systems don't grow anything else than additional functions in ERP systems. And it's also subject to unique economics, which is high fixed costs, at least for the moment, and very small marginal zero costs for actual operation. Now, AI, which is especially generative AI, is interesting change because we don't know currently whether it's subject to similar economics. At least the variable costs are as high or higher than the fixed costs over its life cycle. So it's a very different type of and that's one of the reasons why AI is very difficult to figure out that whether it will make it or not. And as infrastructure, of course, it has resulted in the rise of the data and the rise of the algorithms, which can use this data across multiple settings. And you can use this data seamlessly. It can be connected and processed with, and shared, analyzed, socialized, gamified with little or no cost. So this rise of the fact that you can actually have a separate layers of content and services which evolve on top of the sort of plumbing and the sort of hardware has resulted in this very different environment in which these systems are currently built. Software is used and built. They are not systems. They are certain types of capabilities and functions which evolve in specific ecologies. And there's new aspects of this digital. The first one is embedded. For example, that it is enhanced affordances of physical objects like cars and so forth. And so function is no longer constrained by the form, even in the physical world. It is decoupled, which means that which we have called also loose coupling and dehomogenization. All forms of content can be syndicated as long as we can represent this as bit strings of zeros and ones. Any type of representation of behaviors and states of people can be sort of mapped out. So experience in time, space, interactions can be enhanced in all levels of granularity. And finally, when you have all that, you have this form of generativity, which is that this data can be contextualized, used, applied, and new forms of services can be added on it through interactions between the networks and people, which people call generativity. Which results in the fact that we have this totally new level of combinatorial complexity and unanticipated innovation. So it can emerge in pockets which we didn't not expect before, outside organizations and so forth. And these were not characteristics of Chandlerian system, by the way. And these are the fundamentally different from Chandlerian system. It has its own infrastructure, which we know, which were the sort of trains, plumbing systems, electric grid in a certain form, and telecommunication systems. These characterize largely a sort of infrastructure for the Chandlerian logic. So when you have all these things, you have this embeddedness, or decoupling, representation, and generativity, which raises new types of possibilities. So you have new value propositions. For example, you have a device in a car which delivers which delivered to an insurance company which is decoupled, can better tap customer behavior, which is a representation, and combine with new information like potholes to provide new products for customers, like insurance on the drive. As you drive, depending where you drive, you get different insurance sort of fees. And we can go look at multiple different ways: Weight Watchers, even gamification of like urinal behavior of men in lavatoires and so forth. These are all just examples which you can do actually currently with these types of capabilities. So if you look at these capabilities now, if you look at the research in the digital world, it's very hard to say that what is what and where does it come from. So we need to, on the one hand, new research questions and theories. So we have like open, closed platforms, embedded, more embedded constructs. What do they mean? Privacy and security, combinatorial fit models. How do you new value in different contexts? Dynamic over static models, rapid experimentation, agility, crowdsourcing, innovative creative behaviors. Where do you emerge? Affordances and appropriation instead of system functions. Options logic, which needs to be applied in infrastructures. Business to technology, like causal agency, visions, alignment. It just goes on and on. These are new forms of talk about certain aspects of firm level organizing or community level organizing, and they come with the call for new words and new ways of sort of characterizing new phenomena. And these all sort of originate from these facts. And we need multi-level models and so forth. In the this digital X paper, we said that we tried to sort of articulate what these differences are. And we came up, as I pointed out, 4 elements which are different in this era. The first one is the functionality. That they are now provide unprecedented functionality, which is evolving. It's not fixed like in traditional systems. if you look at it as a sort of infrastructural capability. So outcomes are not caused by digital technologies as such because they're not anymore fixed systems, but they are made possible by rendering causality possible in multiple different ways. And of course, this renders causality in the extant model suspect. For example, do ERP systems generate certain impacts? Because these systems are somewhat different. They are not fixed in their scope and capabilities. So digital technology also transform current relationships and structures and challenge the logic of many well-known social theories as a result of that. Then combinatorial design complexity questions many of the assumptions about planning and design. So the critical outcomes now emerge from experimentation and bricolage, which is largely ignored by past research. And these are main phase of leveraging digitization. And many of the important constructs are located at infrastructure and platform levels, or they cut across the levels, which is different from the past. The technologies are much more plastic, and they emerge from specific interactions with the social, like network effects are basically social behavioral effects, but they are enabled and conditioned by the specific forms of digital technological capability. And so the theoretical models need to reflect the organization's ability to identify, capture, and spread the unique facets of these artifacts and their use, which results in this plasticity in the use and also the value which is derived. And the phenomena is multi-level and recursive, and it should be the corresponding explanatory models. But typically, we have models which are located in, like the theories operate in one level, and they operate with single causal logic, not recursivity. And then economics is that the concepts of digitization as such, not the pure features of technology artifacts and related novel concepts have become instrumental in understanding what the use of this technology and effects are in specific context. So if you look at the script which I outlined before, how does it operate and where does it place our research and the way in which we look at the world? We can look at it from the two words. One of them is that what type of abstraction are we looking for? At what level of abstraction are we looking at the phenomena? And typically, of course, the script aims to increase the abstraction. That's why we pick up the higher level models, and then we sort of little bit sort of move backwards in order to contextualize it to the IT. So that's how and that's where we typically the script places out in terms of abstraction. At the same time, we start from a practical problem typically. So the original port starts with the practical use, and of course we want to solve the practical problem. So we want to increase the practical use, and typically the script places us in a certain point in this type of space between practical use and abstraction, which is sort of middle ground point. That's why we call them middle ground theories, where we sort of trade off some of the theoretical use for the benefit of practical use, but we try to at the same time maintain the sort of theoretical use at a certain level in order to establish the legitimacy and also contribute to the theoretical discourse. And that's how we get these mid-range theories. And we currently have relatively hundreds of incommensurate models because everybody has their way of translating whatever the theories are into each of these contexts. So if you pick up any studies on, for example, IT strategy, it's very different to do meta-analysis because they use different constructs, different ways of measuring that and so forth. It's very difficult to build cumulative traditions on that. But we have very little work which looks at sort of concrete stories of practical use in specific settings, which would be puzzles to be theoretically solved. And we have quite little also work which just tries to theorize about digital phenomena, especially digital phenomena. Because we need to always start with the script that there's some sort of established theory to which we sort of relate. So these are the edges, as I pointed out, which we are largely missing in the current way in which we have published the sort of academic work on information systems. So we have less data-driven data without theory type of empirical work, rich empirical work, and we have too little, I think, indigenous theory, which is theory without sort of data collected for that theorizing. It doesn't mean that this theorizing is not informed by some empirics, so some empirical puzzles. They can be starting points and they can be used as illustration, but they are not used to validate or corroborate whatever you're claiming, because you cannot do that. If you want to do this type of move to this exit, we need to engage much in two-way interactions between the digital phenomenon and abstract theory. So movement in both directions. And engage with theories that do not strictly fit with the current conceptualization of the digital phenomenon. So we have to try to think new ways in which we theorize about the digital phenomenon. We have to relax also institutional norms for what theoretical means and the need for empirical justification as to promote more creative discourse. It used to be so that if you send something to MS Code, I think that they have now relaxed that, maybe because we published this paper, or maybe just they get smarter, that if you wanted to publish anything, you need to have always empirics in it. That was a research paper. That was the only form of theory, research paper. If you had a theory paper, that was a literate view of the past research on the topic, not something which looked forward or which tried to theorize from the phenomenon itself. And we have to fight publication tendencies to add too much nuance, because if we just move on the left to the practical thing as a way to tell a good story, and we have to instead try to move up in the abstraction sayings to thought experiments toward more general parsimonious explanations of these topics. So I'm going to, there are also some arguments against this, so that data-driven research could be the solution, like big data. We wrote a critical review of that and said that it's fine, but it doesn't take away the obligation or the need to actually theorize from around the big data. And the other one is indigenous theory. It's really tough to do. And in order to do that, you need to fight institutional tendencies, which emphasize that you have to use specific tools for it. So then people come back and to us and they say that, oh, well, what should we do? And of course, I don't have a recipe, a cookbook. Nobody has it. But there are certain things which we need to be aware if we want to do a new type of theorizing. The first one is that we have to be much more careful in our constructs and demarcations, what we need, what we mean by the stuff which we are, what is the nature of the stuff we are dealing with, how it's composed, and what assumptions we make about its behaviors. So we assume that we are looking at static entities or static category defined by static categories, like talking about ERP systems and other types of systems? Or are we trying to understand it as a process, this whole thing of digitization, as a process of configuring and explaining how a range of possibilities for new forms of action and interaction emerge? And what are both the technical and social conditions under which these new possibilities and a range of possibilities emerge? If you look at the AI arguments currently, it is largely the question of that there appears to be a new range of possibilities, and we are in the process of configuring those possibilities, but we don't know which ones to, which will realize and why, and what are the mechanisms through which these possibilities might emerge. And this requires also engaging multiple types of causality. I'm not against the sort of efficiency causality or strict causality, so that X causes Y, which is the sort of form of testing, running regressions and validating them and experimental designs. But that's not the only way of the only form of causality. And we deal with much more complex systems. And the key problem with this type of causality is that it's very static and it doesn't sort of look at the change over time. It's much more difficult to explain that. It doesn't understand punctuations in the systems, for example. So, and then finally, we have to understand what are the phenomena of interest. We have to, of course, deal with the social, but and we have to understand the technical and the material, their interactions, basically the hardware and the sort of human behavior. But we have to also understand that there is a mediating layer between, which is ephemeral, which is really important in digitalization, which we call the digital, but it has basically mathematical foundations, but it's also social at the same time. And much of the digital is about the relationships between the social, the digital, and the technical, and their movement over time as a configuration, which we need to be somehow be able to explain. And in this type of theorizing, we cannot look at everything. So we have to know which types of relationships between these elements matter, why they matter in this situation, and how they enable or constrain change, and what type of change, and how we explain that by certain types of causality. And so we have to have certain criteria for inclusion and exclusion, why these matter in these settings. If you look at much of the literature and theorizing, they don't typically articulate very clearly these types of ontological constraints or boundary conditions on what grounds are you theorizing. Then, of course, it has effects on epistemology. So what are the conditions of knowing? And how do you establish veracity? Some level of validity for them. It's easier for brute facts, like what is the speed of NVIDIA new chip? How much heat it generates. These are brute facts. But most of the types of things which we deal with are socially constitutive facts, like affordances. Affordances are not given, they're socially constituted in specific context, and they are only mediated through the social cognition. And so we have to theorize about those things and conditions under which those emerge. And we have to all the time be able to balance between the objective and socially constructed. And you can do either or, that's fine. If you do just objective, you pick up a very computational engineering view. If you just pick up the socially constructed view, the problem which you have with that one is that you actually make technology as a proxy. And if you want to really emerge as a social information scholar, you have to find a way to balance these and integrate these in your explanations, which makes the thing much harder. And you have to understand the material conditions of change. So effects of hardware improvement on the way in which types of digital capabilities you have, which then enable different forms of social cognition and social action. And these are interrelated. They are not separate. They are interrelated movements. At the end, we have to understand how to relate and bridge these different conditions of knowing in our explanations, and because they have different validity and other types of conditions. If you look at much of how much we sort of deal with these, we struggle in writing in these things, but we don't necessarily always have a very good idea how to sort of, especially how we establish the connections. And that's where we should actually work on. So how do we deal with the digital research in settings? And this is just to point out that different choices come with certain potentials and certain constraints. Some they make your life much easier, but at the same time, there are certain things which you will never be able to explain. And you need to know that. There's a lot of work, of course, which I value, and it's very important, is computational research. Basically, new algorithms, new architectures, whatever, new types of technical solutions. Design science work, much of that, not all of that, but much of that is in computational stuff. And that's necessary, but not enough to explain causes or effects nor uses. It is just basically, as you know, the argument there is that this is novel. So it's novel for this X, and compared to others, it's better than that. That's what you need to do. And it's fine. And it builds the sort of foundations for something else in future. But then if you look at the other studies, if you take a nominal view, which says basically, I studied IT adoption or IT use in a certain context, but I didn't look at in any way how the idea was present there, nor did I measure in any way or follow its use in any way. I just assume it's there, which is a lot of research currently in, if you pick up any management journal, marketing, management, general strategy, there's a lot of current stuff on digital. Most of that is nominal. And as I pointed out, most of the IS research had done nominal research, like 50% was nominal. And that's useful to detect difference. If you compare a situation with and without computing as a present, you can detect the difference. But you cannot theorize the impacts of the digital, nor causes or effects, because you didn't really capture that in your accounts. Then if you pick up the proxy view, which is of course valid in especially economics. You look at IT costs, for example, or a level of IT use. That would be another one. Or how often you interact with digital technology daily. These are examples of using proxies because they don't say what you did with the technology, for what types of things affordances was used. It's useful to detect the presence or scale and scope and its correlation with specific outcomes. So scale and scope of this sort of uses. But it's not good theorizing for mechanisms nor processes, as the social context and the actual use setting is not accounted in that. You basically speculate on that. Sometimes of course, you can overcome that so that you go to the field and try to establish a story out of that, which leads to these types of mixed method designs, which is fine. And then you can, of course, look at as a tool which is useful to classify types of uses or detect the presence. But this assumes nearly always fixed context. And if you have a more general idea of a digital, it doesn't enable that type of theorizing. So it's going back to this type of box view of the technology. And you look at one specific tool and ignore the rest of the IT uses in that context. And above all, nearly all of these have certain aspects which go against certain ways in which we may need to think about the ontology of the theorizing. Nearly always they assume static entities, IT as a static entity, tool as a static entity, proxy as a static entity. It is just IT cost, for example. It's typically always in a single context, and the exclusive foreground is either the social or technical, not the relationships. And nearly always you have a single unit or single tech, which you are looking at. And these are fine. I'm not saying that these types of studies are not necessary or important, but if you want to sort of theorize about the digital at the level of infrastructures, we don't get into the actual matter. And that's a challenge. One way, of course, of approaching that is the ensembles, which was about 11% of the articles about 10 years ago. Then you would look at the systems, IT as configurations and assemblages of technical and social behaviors and related social structures and features and their relationships. So you would have to build this type of idea of how these different things relate. You would assume that they are dynamic. They affect and are being affected. So socially affects the technical and technical affects the social. So there's a mutual relationship in both ways. And there are certain these types of relationships which establish existence conditions or emergent conditions for certain types of other outcomes. So these types of interactions over time generate the outcomes. This comes with a certain theoretical assumptions which are hard to carry out. So you need more understanding of fluid and complex objects. So objects which are changed over time. For example, if you do platform research, you might have to look at the platform stack over time and how it was configured and how it might influence it, for example, network effects or certain types of capabilities. You have to assume the simultaneous presence of downward and upward causality, multiple levels. So from the higher entity down to the lower level entities, from the platform to the users, but also the users influence the platform configuration. So there are both ways of effects. You may have granularity, which you have to have at multiple levels. And many times it may imply that you assume like complexity theories, like bifurcations. You may have multiple attractors, different ways which drive the system into different directions, and they are present at the same time. And so after a certain type of change, the system changes, it punctuates, there's a bifurcation, and the new attractors emerge. For example, if you think of ignition conditions for network effects, that's a classical example of bifurcation. Similarly, saturation points. After that, the behavior is different. So one way of sort of thinking about it is that we get like, let me clarify. When we are theorizing, we always have to work with this type of triangle, which is first of all, we have the theory, whatever theory we are trying to build, and then we have the phenomenon itself. And about which we can only get certain understanding through data. And of course, we need to capture all the sides of the triangle in good theorizing. Sometimes we emphasize one, like blue theorizing implies is a trigger, that there's a trigger from certain type of phenomena to start thinking about differently about that phenomenon. It's a theory like a revelation, which blue ocean theorizing generates. But it tries to establish a better cognitive plausibility fit for that type of phenomenon. But in order to validate that, you have to also establish the data, which implies that you have to establish the instrumentation and measure fit with the phenomenon. And as I pointed out in my discussion of these other proxy views and other ones, the problem with them one is that we don't get the type of data which we need to really theorize about this phenomenon as a sort of moving, complex, multi-level system. And then we have to, of course, find out that the theory and the data match, which is the construct fit. And it's like phase and content validity and all these type of things. And of course, you can start with the theorizing in multiple classic form. The script typically starts from deduction. So you have existing theory and you have a certain type of problem. You explain the phenomenon with that theory and you collect the data and you validate that the theory holds for that phenomenon. That's pretty much the script which has been followed. But you can also do induction, and there's, of course, a fair amount of that work, which is that you go to the field, you collect the data, and you inductively derive certain theory which has a fit with the data, and it explains the phenomenon. And then the third one is the abduction, which is that you have a sort of mismatch between the theory and the data, and through that abduction, you try to explain the phenomenon. So the data has some problems. And there are, and based on this, we can say that there's no best way of building theory. All of these are needed. And they can be valuable at certain moments of theorizing when we deal with this type of phenomenon. So what we call this type of approach, sorry to use a little bit colloquial term, we call it the FAFO principle of theory building. And FAFO means fucking around, finding out. So, which is phenomenological theory. So we need to, and we must in different forms of theorizing deal with all of them, like abduction, which is problem-driven. We see the syndromes and try to explain that, which leads to either to deduction or inductive approach, and then we may have to actually integrate it in other forms. And archetypes typically are you problematize through abduction, so the phenomena comes first. Or you explain patterns through the data, which is the data first. That's the big data research. Or you question why extant theory doesn't work. That's the theory first. But it's a different than the current where we said that you assume the theory works. Or you can start with the anomalies, like anomaly in the phenomena. Phenomena doesn't make sense. Or anomaly in the data. Data patterns do not make sense. Or anomaly in theory. The theory doesn't make sense in this context. And that by doing that, you sort of expand the search space around which you are going to theorize. It may lead to new data, new ways of thinking about the phenomenon, and so forth. So there are several challenges in this way of doing that, which is the units and properties and the relation. Which units you should look at? How to theorize of the interactions. That's probably the key challenge, and especially multi-level interactions. And you have to also understand, as I said, they are changing, moving objects. So how do you explain the history, path dependency? It always matters. And what to include and exclude. You cannot do everything, but you cannot either side sort of return into this very narrow system-based view. So you have to find certain constraint spaces for explanation. And you have to assume that there are not a single best static choice, but the key analysis should focus on explaining certain type of change and interaction. So you should always start with a certain phenomenon within levels and between levels. And of course, this requires over time we have to fix or modularize interactions and effects. That there are certain typical, essential, critical, which leads to these growth patterns or the changes or something like that. And one way of thinking about that is looking at this digital stack and understanding how the stack changes. And that's why I have been working on this. I'm not saying that it's the only one. So you can look at the loosely coupled architecture as a way of theorizing about the change in digital phenomena. So how interactions between certain layers sort of enable certain innovations which lead to new interactions or capabilities and possibilities in other layers, which results in a certain way of configuring the whole stack differently, which enables certain new base of behaviors. And then you have to think about like different ways in which this digital becomes embedded. So it needs to be materially embedded into the devices, how this changes, or how the digital can connote or denote new types of things or behaviors or states, which is the virtual embedding, how you can combine them. You can innovate on that. That can result in new types of stacks, or you can pick up the whole stack and embed it in a new context or with the new features. And all these may result in new types of changes. Oh, sorry, but wrong diagram. And another way of thinking about it is exactly this change. So you can think about that in terms of like horizontal growth, which is that contents and service layer changes over time in a certain context. For example, evolution and introduction now of AI tools is largely horizontal growth. You introduce, for example, you think about Copilot. You introduce that in a word. That's a sort of horizontal growth in the capabilities, how you write and interact with digital objects. And how does it then influence in specific context the way in which this writing happens and what the effects of that are? The other one is that the way in which you map the service and content stack layers into the networks and device layers may change. So this may have all types of other additional elements. And then the device layer can expand over time. Like you can add new sensors, new types of devices, put them in new settings, and you can add new types of form factors. This may change, even with the same stack, it may result in new types of capabilities. And you can add new types of vertical interactions with them, like the level of coupling, the path through which the content and service reach the device at the runtime may change over time. The scale and scope of this stack and its capabilities and economics may change. And there's a certain form of emergence in the sense that as a whole, it provides things which none of this separately does. And you have to understand this emergence. When the certain types of changes happen over time, new types of behaviors become possible. There's a lot of bets now that if AI is put everywhere, that there's going to be this new emergence of a totally new way of sort of organizing, for example. Whether that happens or not is exactly the type of research question we should be focusing on. And then there are, of course, issues about economic benefits and other things like critical components. What are the critical components in stacks and what is the control? Who controls what? What does it matter? So this is my last slide, and I went a little bit probably too far long, but if you excuse me. So if you think of these forms, you can think of certain forms in which you can theorize. One way which I'm proposing, I'm not saying that's the only way, is to think in terms of more abstract terms, what the digital is, not in terms of systems, but in terms of stacks. And analyze the stack change and mappings to material and social worlds, how they evolve over time, especially the virtual new meanings emerging through digitizing, and then how these are embedded in specific behavioral settings. Which movements and configurations matter, really generate the change. What constrains these movements? What stack abstractions work and which settings for which questions? So as a design or projection or imagination for the type of change. And then we have to also build ways to theorize simultaneously across and between multiple stacks, because actors engage in multiple stacks at the same time, and firms operate multiple stacks same times. And they apply them over time and across different settings and populations. And how do they manage this as a whole? How control is established within the stack? We talk about control points, but I don't think that we really know what that means. Which interactions allow systematic accounts and local explanations of cause and effect? I think that much of the cause and effect emerges from the interactions, enabling or constraining certain interactions in these stacks across these three embeddings. That's one way of sort of getting into the causal explanations. And of course, this is a very initial framework. It needs much more methodological advances in operating stack measures and presence and effects. And we don't really know about those things. But I think we need to think a little bit differently about the digital, and this is just one very humble effort to try to sort of move to that direction. And it's, as you can see, it's still in the very early stages. But I thank your interest in this, and I'm stopped sharing and we can talk.